ArtEmis, effective language for visual art. A fundamental problem in computer vision is to teach computers to understand visual content. So far, we were able to teach computers to understand images through tasks like classification, object detection, segmentation, depth estimation, and even using our natural language for image captioning. However, datasets used to train existing deep learning algorithms contain only objective or fact-based information about visual content. In Coco, for example, each caption refers to objects and actions directly visible in each corresponding image. But humans have much more complex perception system as well as affective component. We may have different feelings or emotional responses when we see different types of images. Therefore, we present a novel large-scale dataset called ArtEmis, Art plus Emotions. We focus on the affective experience triggered by visual artworks and ask the annotators to indicate the dominant emotion they feel for a given image, and crucially, to also provide a grounded verbal explanation for their emotion choice. We focus on visual art because art is often created with the intent of provoking emotional reactions from its viewers. Secondly, artworks and abstract forms of art in particular often defy simple explanations and might not have a single easily identifiable subject or label. Therefore, an effective response may require a more detailed analysis and integrated the image content as well as its effect on the viewer. The ArtEmis dataset is built on top of WikiArt dataset, which contains more than 80,000 artworks. The annotators were hired through Amazon Mechanical Turk to ease the cognitive task of self-identifying and correctly selecting the dominant emotion felt by each annotator. We display expressive emojis to accentuate the semantics of the available options in the user interface. ArtEmis exposes moods, feelings, personal attitudes, but also abstract concepts like freedom or love are grounded over a wide variety of complex visual stimuli. The annotators typically explain and link visual attributes to psychological interpretations, highlight peculiarities of displayed subjects, and include imaginative or metaphorical descriptions of objects that do not directly appear in the image, but may relate to the subject's experience. We show that captions of our dataset are richer and more diverse in terms of nouns, pronouns, adjectives compared to existing datasets. We carry emotion-centric analysis and show that ArtEmis has significantly more abstract, subjective, or sentimental language compared to Coco. Building on this data, we train and demonstrate a series of captioning systems capable of expressing and explaining emotions from visual stimuli. These neural speakers are nearest neighbors, adjective-noun pair, and state-of-the-art captioning models, show what and tell, and meshed memory transformers. Here we report the machine-induced metrics and also show that well-trained speakers create sophisticated explanations that cannot incorporate nuanced emotional understanding and analogy making. These examples demonstrate the effect of grounding our neural speakers with the desired emotional reaction. It is interesting how the speaker can adapt the explanation to reflect the desired grounding emotion while staying relevant to the content of each painting. Even though the neural speakers produces pragmatic explanations that include visual analogies, looks like blood or dead animal, and nuanced explanations of affect, sad and lonely, expressive eyes, they are far from perfect. Here we see how our neural speakers can make mistakes at the basic object recognition level of reasoning. For example, the moon is shining down on the water, or the man is holding a naked body, which is sad. Or they suffer from mod collapse. For example, output the same caption for two different images. At the end, we thank our collaborators for their great effort and hope our work will open new doors in computer vision research. Thank you.